Welcome to the Brainstorm with Sparks and Finn, a podcast where we brainstorm the science and philosophy of a new age, an electric universe age, and what it means for the human race, past, present, and future. I'm Finn, sci-fi author, artist, and future god emperor of all puny humans once I merge my weak carbon brain with AI.
And I'm Sparks, physicist, experimentalist, and master of Mexican judo.
You don't know if I got a knife? You don't know if I got a gun? You don't know if I got my homies around the corner?
Today's springboard topic, geology and the sun.
Yeah.
And today's guest, an author, independent researcher, and a writer so prolific that Gutenberg had to lobby Congress to take away his typewriter time. Introducing Steve Smith.
Hi there.
Buckle up, ladies and gentlemen. Let's see where it goes.
So the idea is that we start this with a springboard topic of some sort, which is the geometry in the sun, or the geology of the sun, and then we'll just kind of go from there and see where it winds up going. I guess we're stepping into a brand new paradigm where all the things that we've heard before aren't true anyway if the mainstream model they're built on isn't true. So we're just philosophizing, shooting in the dark, and we're some of the first people to do it under a new paradigm. So there's some value in that. No one's expecting us to be spot on with our musings, but hopefully greater minds will take it from there.
It's an incomplete paradigm shift. It's a process.
Right. I remember Steve talking to you last year, expressing my lament that the more I learn, the less I feel like I actually know.
Indeed.
Yeah.
That is a time-tested paradigm right there.
Right.
So Steve, illuminate us. Geology of the sun.
The geology of the sun.
What is it?
Oh, the geology and the sun. Because geology doesn't really appertain to the sun. There's no geographical features, although some people think there are. That there are mountains on the sun, for example.
Spicules.
Yeah, a lot of these granulation and things of this nature, people actually think, though, that there's structure on the sun because the sun is a solid iron object. This is their ideas. That's one consequence of thinking of the sun as something other than plasma. Is you get a solid object underneath the plasma layer.
That's kind of what I think too, I guess.
Yeah, like Monte's electrode.
Yeah.
Monte's electrode is necessary to create the electrical features that we see. So naturally you extrapolate, to the large scale and think, well, the sun then must have a surface on which electrical phenomena can occur.
Steve, let me just stop you there for a second. For those who are maybe new to this whole paradigm, could you just tell us real quickly who Monty is and what the hell you're talking about?
Really? We have to go back. We have to go back that far. Okay.
No, just a couple sentences.
What's Monty's last name? I can't.
Childs.
Monty Childs. That's right. Monty Childs and Robert Anderson were two people who Dave Talbot of Thunderbolts Project. In fact, he's now the head of Thunderbolts Project, so to speak, because Wal Thornhill has passed away. They were the two co-founders. And Monty and Dave got in touch because Monty and Robert Anderson were working with Six Sigma testing facilities with the Air Force. And that means, 6 decimal places to the right of 0. So they were analyzing things at very small scales and at very fast speeds, and particularly electrical concepts. So what they wanted to do, and had no method of doing because of lack of funding, was to create a sun simulator for all intents and purposes, where they could generate electric currents and electron voltages similar to what's on the sun or in the sun or a part of the sun in any way you want to think of it. So they originally developed a small device inside of a glass jar that they could feed various gases to and various voltages and measure various things. And they apparently discovered that they were creating plasma discharges inside these jars, and or this jar, because they made one. And inside those discharges, there was transmutation of elements and nested circles around the electrode of varying voltages, electron voltages, and varying plasma velocity.
John Scott's double layers.
Yeah, double layers, and each element in a plasma has its own characteristic velocity. So it will go out from the center, and then the other element will go out from the center, and they're confined in electromagnetic fields because they're double layers from each other.
Which is negative, positive, repulsing each other away from one another.
Yes, double layers.
You get closer to the center, it's accelerating those particles faster, correct?
Right. Faster.
That's why you get that pinch point in the middle.
Yes.
So what I was wanting to get before we get too into the weeds with this, Monty, and what all this started out, or what it became was, of course, and I'm sure you're getting to this, Steve, is the Sapphire Project, SAFIRE.
Yes.
The star in the jar.
Yes.
That's
basically what I'm describing. An electrode inside of a jar whose atmospheric pressures and compositions can be varied. And that's what they're trying to say, that's what's going on the sun and in the sun, that it's a variety of elements that are manifesting in a variety of ways, because plasma is not understood. And before we go any further, we have to say definitively, no one understands the sun. No one. All the things we're talking about are just our best guesses. The mainstream is the same.
Right.
They think it's a gravity centered object where gas and dust is compressed into a ball so tight that it heats up to fusion temperatures, millions of degrees, and therefore starts streaming out these high energy photons that take 1 million years to traverse through the matter of the sun and then finally radiate from the surface. This is their explanation of where solar energy comes from.
And let's not forget that the surface of the sun in that model is cooler than the atmosphere.
Yes.
Which
well, we haven't even gotten anywhere near that yet.
Yeah.
Because we have to consider that the sun, if you're considering the sun as a compressed ball of dust and gas, what kept it from heating up and expanding as it compressed?
Right.
They have these bizarre additions to this theory where the hydrogen was cold, as if starting with cold hydrogen, I mean, how else is hydrogen going to be in the vacuum of space? Starting off with a gaseous cloud of cold hydrogen and other additive gases is supposedly that supposedly prevents it heating up. It collapses.
And Eric Lerner had finally to say about that too, just on the amount of hydrogen that was actually in space at the time they hypothesized this occurring.
Well,
so if that's inaccurate, then where'd they even get the hydrogen from?
Yeah, that even itself is a complete non sequitur, because you have to first of all deal with the number one law of thermodynamics, that if you compress a gas, it heats up. The molecules move faster. I mean, they proved that back in I don't know who was the one of Priestley and these other guys when they were testing gases and trying to figure out gas pressure and thermodynamics in general.
Boyle's law.
This was all known, You can't compress a gas without it heating up.
Yeah.
And they want to compress this gas to fusion temperature and then have it suddenly release this anti-thermodynamic phenomenon that they're presupposing is going on. But that's all nonsense. This is nonsense.
Would it be fair to say that we are unable to create the kind of convection layer that would make the hot core cool off and be cooler than the surface temperature, and then have the upper atmosphere be 20 million degrees as opposed to thousands of degrees?
It's impossible because you can't generate a force within a force that counteracts the force. So you can't compress the gas and create a portion of it that isn't compressed. That's just nonsense again. You can't.
And so that brings us to super condensed matter, which we've only been able to create some small version of that in CERN, which is stable for a few seconds and then becomes too unstable to observe, if I'm correct.
What is super compressed matter?
Fiction?
Like slamming the two pellets of hydrogen together, that kind of thing?
Yeah.
Like they do with a tokamak?
Yeah. Well, CERN runs charged particles through an electric field, and that's how they gain their magnetic field and accelerate.
Oh, the particle accelerator. Okay, yeah.
Yeah, which is ironic because if the sun's electric, it's giving off an electric field, and charged particles going through it are accelerating.
Well, they're essentially colliding two lightning bolts into each other, two positive lightning bolts. You know, protons are nothing but electric charge. They're not physical objects. They're not throwing billiard balls at each other. They're throwing a quantum of electric charge, or billions and trillions of quanta of electric charge, because that's the only way they can get one or two of them to collide. Because
so in your opinion, what is CERN doing?
Well, they want to repel. You know, this proton beam, well, they use protons and antiprotons now, so that they don't necessarily want to repel so much. So they throw a proton and an antiproton beam at each other. So that's how they're doing their collisions these days, because it was too difficult to collide two positive charges, especially with the force of a proton. You know, for its mass, its charge is tremendous. It's substantial.
When they talk about all this, and I just have to sit here and shake my head so many times, because every time we talk about standard model anything, we run into that scenario where it feels like there's 5 blind men each feeling up a different part of the elephant.
Yes.
And the standard model is just one of these scientists grabbing hold of the leg saying, mine is the correct version.
Right.
And you're like,
duct tape it
some
all.
of us outside of this are standing back going, no, we can see that there's 4 other people grabbing different parts of this. So what about what they're saying? And they're like, just ignore what they're doing. You're like, why? This doesn't make any sense.
Well, you know, they stand on the shoulders of giants, you know, which is something they should not be doing. They should be jumping off those shoulders.
Or as like Wall said, the giants are facing the wrong way.
Yeah. Well, they're the ones propping up, you know, they're propping up mainstream ideologies because they're the giants, you know. No one dares jump off their shoulders. It's too far down. It's the end of your career.
Let's call it idiotologies.
Idiotology, yes. That's a little hard.
That's going to make us popular.
No, it's not.
No, it isn't. No, they deserve all the foolishness they can acquire.
Yeah.
So let me just interrupt right here, too. For those of you that don't know, who are watching this for the first time and are just being introduced to Steve Smith, you need to know that he is an extremely prolific author. He has written 1,700, in fact, every single one of the Teapods. Steve, what are the Teapods?
The Thunderbolts pictures of the day. Well, they started out a long time ago in 2005 with Mel Acheson and his wife, Amy Acheson. Amy Acheson was an astronomer, and she was friends with Halton Arp. So
I didn't know that.
Oh, yeah. They got the attention of Halton Arp, and that's why some of Halton Arp's talks are in front of Electric Universe or Thunderbolts Project audiences back in the day.
Yeah, he kind of went our way a little bit toward the end, didn't he?
Oh yeah, yeah. Well, he was surprised. He was surprised to find people who were curious about intrinsic redshift.
Yes.
Because redshift is a bad idea. Let's just say capital BI.
Doppler effect in space.
That's a kind way of saying it, yes.
Redshift is supposed to occur because of Doppler effects, like if the faster an object goes, you know how a train comes towards you, it goes as it goes away. And that's what they think is happening when stars fly through the universe. Their light is going compressing and expanding, like light can be squeezed. Because
reasonable, space, I suppose, until you run into Halton Arp and his observations.
Well, they say space can be squeezed, and that's why light is being extended. Light is being expanded by the expansion of space. So even though the universe is supposedly 13 billion light years in diameter physically, it's like 138 billion light years because of spatial expansion. When you put spatial expansion, so that means galaxies at the edge of the Hubble, the observable universe, can never be seen because they're accelerating away at 99.9% of the speed of light.
But what did James Webb say about that?
I don't know.
Well, now we're discovering galaxies that are way further away than they're supposed to be.
Right.
Yeah. Yeah. Now they've got the red blobs. What are these orange red blobs that we're seeing here where we're not supposed to be seeing anything? Now everybody's going, oh, it's another universe. Oh, it's the universe before. It's the universe before ours.
So this is, of course, I'm holding up a ruler, and this is one of the biggest problems with Einstein, which he was very well aware of. He and Wall has brought this up multiple times, and it relates with what we're saying here, that if you do not have a standard yardstick, a standard measuring stick, then everything else that you use this for is irrelevant. It makes no sense. If your yardstick can stretch and compress, which is what Einstein tells us what space does,
that makes it tough to measure.
Is obsolete. It's not obsolete. It doesn't make any sense.
Well, Minkowski's responsible for that crap.
Oh, really?
Minkowski was Einstein's teacher, his professor. And Minkowski, his famous idea is you have 3 dimensions of space and 1 dimension of time. So that gives you space-time. So space-time is actually a sphere embedded in a hyperspace.
That's retarded.
So our lives are like little pink worms embedded in this crystalline sphere. There's no such thing as free will because space and time are one. And when you're born and when you die are already extant in space-time.
Well, that does jive with simulation theory, though, because think of it as the creator being outside the server looking at the game he's already made that runs front to back. But it doesn't make any sense because time is not a physical object you can manipulate. It's an abstraction, like a forest to trees.
Space is not a thing either. Space is the stage upon which things happen. Space is not the stage itself, nor is it any of the things. It's merely the 3-dimensional expanse in which things happen, creating time. When things happen, time happens. When things don't happen, time doesn't happen. So there can be no non-motion because there can be no non-time. There's no zero time.
Was that you talking about the sink that turns on and one drip goes into the void of space and then it vanishes? And then again, at some other undisclosed point of time, it happens again. And so you ask the question, well, how much time has passed? Well, we don't know because in order to measure time, we have to have 3 different things. You have to have, I might be mucking that up, but it's
3 different instances. You need a comparison.
A chronological thing like a heartbeat, something that's going to occur over and over again. And then you have to have distinct something that happens here, something that happens there, and then the heartbeat to measure the time between them.
And
Otherwise,
you have to have a mind. Then you have to have a mind to make up this stuff.
That, Steve, I think that's the key. That's the foundation that gets ignored time and time and time again. Because there's an idea in quantum physics that Einstein rebuffed at. He said it this way. He's like, I refuse to believe that the moon doesn't exist when I'm not looking at it.
Yes.
Now, here's the interesting thing about that. You two can close your eyes and I can look at the moon. I see the moon.
Hmm.
However, for you two, the moon does not exist.
Well, I'm a solipsist, so you guys don't exist anyway.
Wait, does
That
that mean
explains everything.
Yeah, I understand what you're saying, that Einstein didn't like spooky action at a distance. So that's why he was having trouble with quantum fields.
Right.
You know, in a sense, if you follow modern, explanations, quote unquote, we're all nothing but quantum fields. There are no particles. There are no things. Yeah. Nothing is a thing.
Yeah.
So space and time are not things. Energy is not a thing. Matter is not a thing. This philosophical idea of materialism has to be sort of gotten rid of. Materialism is one of the banes of philosophy, thinking that everything is,
tangible. Well, I just did a Thunderbolts about scale in space, where Wall discusses that 1 AU is the distance from the sun to the earth. And if you turn that into an inch, then it's something like a full arm's length to get to, Jupiter, and then, to get to the end of the solar system. And then from there, the nearest star is 5,000 miles.
Mm.
And at those scales, the sun is 1/100th of a millimeter, and planets are just like molecular size. So if you think about it that way, there's, and also if you add that this could be the molecular structure of some larger reality above us, then there is no physical material, almost nothing. I mean, a couple grains of sand amongst fathomless distances.
Well, there's only one atom in 10 cubic meters of space between galaxies.
Yeah.
Which is amazing.
That's pretty empty.
That's pretty empty.
I used to say there aren't that many particles, but there are a lot of cubic meters.
Yeah.
So you can still transmit electrical fields through space because there are charged particles sufficient to carry the electric domains.
Yeah.
Steve, I'm glad.
Huh?
Sorry, I'm glad you brought that up, because just before we started today's podcast, I was reading one of your Thunderbolts called "The Interconnected Sun."
Mm.
It's one of your longer ones. It's 10 pages, but you specifically address this point of how there are temperatures that are crazy high, but for us measuring them, with our cute little instruments, it would be very, very cold.
They would freeze.
Right. And you discuss the density of particles versus the movement. So you can we say that temperature is when things vibrate really fast, right? But if those things that are vibrating really fast are separated by huge amounts of space, we say, "Oh, it's really cold." But is it? It's not. And you make that point very good. And if anybody hasn't read this, I highly encourage you to go back to the Thunderbolts website and look up the Interconnected Sun Teapot and read through that. Because you also describe not only is temperature can be really high, even though it's not connected to another molecule, but that you can get a big, huge, not arc, I was going to say arc discharge, but say it again.
A resonance, a vibration.
But you can also get current flow is what I was trying to say. So even though to us it looks like there is no current in space, there is massive current, to the point of, you put a number down of like 10 or like 1,000,000 volts or amperes, not volts, amperes. In fact, let me see if I can scroll back and find it.
Charge differential, right?
What's that?
Charge differential.
Yes.
One of the, in one of two of my teapot. Oh, by the way, that one teapot, The Interconnected Sun, was published in Japanese in a print magazine.
Oh, nice.
Yeah.
What did the Japanese think?
They liked it. The
Okay.
Japanese really liked the electric universe. In fact, they did a TV show about it.
Really?
Back in the day when Talbot first came out with the ideas, they actually did a TV production about Talbot and the electric universe.
It was a Japanese scientist that busted the mainstreamers trying to Dr. Haltnarp's first photographs, wasn't it?
I don't know.
I haven't heard
You
that.
mean by overexposing the?
They actually tried to Photoshop out, or maybe, I don't know, whatever tricks they used at the time. They tried to conceal the plasma bridge.
Yes.
And then he released this book, Peculiar Galaxies, with like 1,000 pictures of them.
Yeah.
But it was a Japanese guy. I don't know his name. I heard it on a teapot a million years ago, but well, maybe that's why.
Okay. I found this. It was, I misspoke just a little bit. You talked about how the Themis satellite, THEMIS, detected these space tornadoes, which were conducting about 100,000 amps. And these were the ones
spinning
that, like,
at 1,000,000 miles an hour.
Million miles an hour, exactly.
And they're 60,000 miles in diameter.
Wow.
There's two of them. They come from the sun and connect directly to the Earth's magnetosphere.
Oh, wow.
And they direct the sun. See, people think the sun is like an anode glow, that it's radiating like this in all directions, but that's not true. It's extending filaments into the solar system, and they're all twisting and tangling, but primarily the solar radiation comes out as a filament, not as a diffuse glow.
Right.
Not unlike a plasma ball at Spencer Gifts, right?
No, somewhat like those.
Yeah, that's right.
You touch the glass and they come.
Yeah, something like that. And but that's the whole principle, is that the sun is not just a diffuse glow. It's actually wound up in these tornadoes. You know, each one of those spicules is those 60,000 mile diameter tornadoes, each one of them. And they're going all sorts of places, and these two are connected to the Earth directly. They're probably there all the time.
Yeah. Is that our Birkeland current?
Those are Birkeland currents.
Yeah.
Good.
And Don Scott's got a video on.
Well, they are like Birkeland currents, because technically, to be precise, Birkeland currents come in with the aurora.
Yeah.
And go out on the other side of the aurora.
Right. So these are different.
These are not those. Yes.
Oh, okay.
Although the same sun is driving the two phenomena, they are not the same thing. Like the sun,
what would be the difference in their function? If a Birkeland current is essentially our main power in and out, what do the other spitules do? Don't know.
Nobody knows anything about that.
Wait, maybe some.
We only know, we're just beginning to acknowledge. I mean, the mainstream is just even beginning to acknowledge that electricity has something to do with the atmosphere, but whatever it could be.
So let me take a step down this road, Steve. I'm going to agree with you and disagree with you. I don't think we have the big picture at all. However, some of the things that we have learned, and one thing I've learned here just fooling around in the lab, is that when electricity flows in free space, it goes filamentary. Now, not every, and what you said, not every filament is a Birkeland current.
Well,
but every Birkeland current is filamentary.
Filamentary.
Yes.
So I think we do know that.
Right. Birkeland currents have two, what do you call them? Manifestations.
Counter-rotating cylinders?
Or more. Yeah.
Right.
Yeah, Don Scott's video actually shows the counter-rotating cylinders in the Earth's aurora.
Yes.
And of course, we can see it on Saturn and Venus and Jupiter and all these other places too.
Do you know who Lathwaite is?
Yes.
The
Eric Lathwaite,
pioneer. Eric Lathwaite.
Yes.
He was a professor many, many years ago, primarily in the 60s and 70s. He is one of the people who's acknowledged as responsible for creating magnetic levitation.
Right.
Oh,
yes.
And he was having trouble keeping his magnetically levitated objects in place. They wanted to slide off from the sides because of the dynamic forces the Lorentz forces as the object is floating on the magnetic field, they want to go right-hand rule, they
Right-hand rule,
move
yeah.
one of the other ways. So Lathwaite discovered that if you took a magnetic, if you took a cylinder and put a magnet around the outside and filled it with cement, and then put another magnet in that place and filled it with cement until you had like 4 nested cylinders of these circular magnets, they would create an inward moving magnetic field. So the magnetic field would move from the outside to the inside. And by setting your device or whatever object you wanted to float on that field, because they were moving like this, sweeping towards the center, it would stabilize it. And that was the key breakthrough to keep the objects in the field.
Right.
So I asked Don, it seems like what you're describing is Eric Lathwaite's whole process. You've got a magnetic field spinning this way, and then you've got a magnetic field going this way and another one going that way. I said, do you think that's what's stabilizing the stars?
Mm-hmm.
That it's focusing it, that you have an inward traveling electromagnetic field from the surface of the star toward the core. So therefore, you don't necessarily have to have a solid in there at all.
Mm-hmm.
You just have a field of force that's stabilizing the star, because the star is sucking electricity in from the galaxy.
Sure.
So it's all
on a side note, Don Scott's model, when you look at it from above and you lay that Birkeland current over the top of the solar system, there are certain cylinders where matter concentrates. And if we overlay that over the top of our own solar system, that's where we find the planets.
Mm-hmm.
And
there you go. That's a very good point.
Mm-hmm.
That's a very good point.
It's also mind-boggling the size of the Birkeland currents, which is something I had no idea. Ben didn't either. When we realized that our heliosphere, the outer edge of our solar system, the maximum range of the sun's reach, that's the pinched in point of the Birkeland current that we are in. So you could think of a Birkeland current as like a big plasma garden hose with a bunch of these little disc-shaped electric motors running along it, all of them sucking in charge from the collapsed field of charges we call the ether, or ether, if that's what it is. I don't know, but sucking in electrons at any rate.
So another thing where you just said that it's the magnetic field and the spinning that helps stabilize things, that may very well be the case. I think there's another, and I'm not saying it's one or the other of these, but when you have stable areas or stable islands, that's also very indicative of resonance.
Yes. Islands of stability. Yeah.
So to say that, I mean, if we have electricity flowing in space, which we know we do, we're going to have resonance, especially within a stabilized system. So to say that there's not resonance, or that resonance doesn't play a role in where our planets are, I think is just fantastically ignorant.
Yes.
It's got to.
Like Don pointed out, you can't have neutron stars because they violate the island of stability rule.
Exactly. That.
Can you explain what that?
I can't. No. Ben probably can. Island of stability. It's something about how atoms arrange themselves. They have to be within certain energy domains, or else they can't. Like, you can't have pure neutronium. Because you have to have charges distributed appropriately within the molecule or the atom.
Right.
So if you have all neutrons, it'll all fly apart.
Sure.
Because neutrons are not stable.
You can think of it, right, Steve, that was a great way of explaining it. You can also envision it like this. These are magnets, right?
Mm-hmm.
And of course, everyone knows that a magnet has a north and a south pole. It's very difficult to see which one would be, which is the north and south pole. But as you bring them together, of course, the north is attracted to the south and the south is attracted to the north.
Right.
It is ludicrous. In fact, you could take other magnets, which I have right here, and paint them red and black, or red and blue, and it would be ludicrous to try and put all the North Pole magnets together. They would not stick. You could physically see that.
Right.
And that's the same concept as the island of stability.
Right.
Is that it's just ludicrous to think that you can put these particles, these nuclear particles, in any configuration. No, you can't. In the same way that you can't put magnets together in any old configuration.
And
They will align.
that
So it
probably
reminds me
explains
of things-
orbital mechanics, yeah?
Well, maybe part of orbital mechanics, but I don't know if the orbital model of the atom is correct.
Huh.
You know, it may not be an orbital model. It may be a resonant plasma phenomenon that makes atoms and molecules.
Yeah.
You know, waves reinforcing each other like caustics. You know, and that's where you get what the phenomenon called matter is. And then where there are no caustics, then you have what the phenomenon called space is. So, you know, I don't know. I don't know any of this stuff.
That's why it's
I
so
mean, I only have an inkling. You know how broad this topic is, you know, where you want to talk about plasma, you know, supplementing matter or gravity as the primary force in the universe. Well, well, let's just disassemble the universe, you know, and throw it on the table.
Why
Now
not?
what?
Okay,
Now
well,
we
let's go
gotta
back
make up
to
new rules. We got to make up all new rules.
let's go back to what's in the center of the sun. So we've got could be a metal solid. I guess I'm a believer that gas giants are planet factories, and the bigger they are, if they're the dominant feature in their solar system, the most powerful electrical cathode, I guess, they're going to attract the cosmic Birkeland current, and they're going to ignite either into glow mode as a red dwarf or a brown dwarf, or they're going to ignite into arc mode like our sun. And if they are the dominant feature, then all the other gas giants will not ignite because they are in our solar system. Is that nuts or what?
Well, I don't think, well, we talked briefly about Uranus the last time.
Hmm.
Thornhill's major contention is that all the four gas giants were captured by the sun in
Right.
separate, however long periods of time over whatever. You know, Duardu used to think it was over millions of years that these gas giants slowly assembled into the solar system. But my idea is that the original thing that happened was we ran into another star, that the sun, we ran into a star called the sun, a yellow dwarf, and we were circling Uranus, a red dwarf with a far lower electrical potential.
Right.
So when we entered the sun's domain, the potential in that star, that cold star, or even, you know, glowing star, increased to the point where it had to go and become two stars orbiting each other in order to spread that increased potential along its fields of force. And as we got even closer, then those two just went and tore themselves apart. And now we have four. We got into the space where the balance between the objects and the field potential solidified, so to speak.
Sure.
So now those gas giants stacked up in their characteristic ionization velocities, you know, so they're this far apart. Like Jupiter's plasma tail actually tickles Saturn, it extends that far.
Right.
And Saturn's doesn't quite reach Uranus because of the distances. They think there might be something missing between the two, between Saturn and Uranus. And thus, Uranus exhibits a chaotic interaction of some kind by laying on its side, for example. So something might have passed by, right? And disrupted the electric potential of the solar system. Who knows what it was or when it was or anything of that nature? We can't tell at this time because we're divorced in time and space. We can't tell anymore.
Yeah.
You know what? That's kind of discouraging to hear that being said out loud. However, I get a little bit of hope when I realize that it may not be so divorced from our knowledge and understanding if we get enough people looking at it.
Maybe.
Because right now, the current model they have their idea on how the solar system works. Uniformitarianism is the rule. Well, what
Gravity.
happens when we set uniformitarianism aside and say, okay, now let's look at all the data? And I
We're
think James,
trying. We've been trying.
no,
Everybody's
right.
been trying for a long time to go up against the gradualism of science, like geology, for example. Everything depends on a slow, constant, steady, infinitely long period of time. And
I
once
suspect we're past that a little bit. I think things are going to change a little faster now.
maybe I see things
It could be
changing.
my wet behind the ears young guy approach, but I
see
suspect things are changing.
I
That's
do.
a
I
really
see
good
things.
that's a really good dovetail for our topic, because we said we were going to talk about geology and the sun. We've talked a lot about the sun. Let's move it into geology. And let me start off with this. We all know that the sun, we've established there's an electrical component to the sun. It spits out CMEs, corona mass ejections, every once in a while. Some of us monitor that. I do, right there. And those corona mass ejections, as every single electrical engineer everywhere knows, causes induction. Well, induction in what? Induction of everything that it passes. Well, does it pass the Earth? Yes, absolutely. So does induction happen in the Earth when the sun burps out a CME? Oh, absolutely. And that, I think, is where the geology aspect of it comes into play. Because as you know, when electricity interacts with matter, it does it in very repeatable and specific ways. Now, I don't even think we've discovered all the ways that it can interact, but we know a couple things. One of them is it creates a double-lobed feature. And I think, Steve, you've written about this with comets on some of your thunderbolts. I don't know which ones. I could probably look it up. Do you remember?
Peanut-shaped comets?
Huh?
You mean peanut-shaped comets?
Yes, peanut-shaped comets. Steve, have you written a Thunderbolts or a teapot exactly about that?
Probably because I wrote about 67P and I wrote about Arakoth and I wrote about all the other comets that had lobe-8 shapes.
I might have narrated a couple of years. I did.
I was trying to find something here. There's a teapot I wrote about electric currents underground.
Oh, yes.
Oh, yeah. Lightning, earthquakes are lightning underground.
Earthquakes and lightning.
I narrated that one.
Yeah, earthquakes and lightning. That's the one. And that earthquakes could be lightning bolts underground, and their seismic waves are the shock waves.
Mm-hmm.
So those are created by connection with the sun. The sun is directly connected to those underground, what do they call those?
Telluric currents.
Telluric currents, that's right. So the sun is directly connected with these underground telluric currents. So whenever a CME occurs, or a what you call it,
flare, X-flare,
a solar flare, that is injecting additional electrical energy into the strata, into Earth strata. I mean, directly, like a transformer. It's like a three-phase transformer. The sun, the ionosphere, and the telluric currents. They all have their own pole, connected to the main transformer, and they're getting variations in their AC current flowing from the sun. So, you can imagine. Did you ever hear of the Bastille Day solar flare from back in the 70s and 80s, where a CME from the sun arrived at Earth in only about 15 minutes? A bizarre, traveling near the speed of light, this gigantic X flare.
Yeah, it's half the speed of light, right? It takes light 8.5 minutes to get here.
Yes.
That's fast.
That's very fast for a CME.
But a solar flare or a CME isn't light. It isn't an electromagnetic. It's energy particles. It's mass. So this mass was traveling close to the speed of light
And that would require an electric field to accelerate it, right?
God, yes.
Yeah.
So now we're thinking, oh, where do these electric fields live? Could they possibly live somewhere in the solar system or outside of the solar system? Could these kilonova size bursts of energy that they're detecting now be where some of these solar flare actors live? You know, maybe we don't know what's out there. We have no idea what's beyond our electromagnetic field.
Yeah.
Because then you're in the ISM and we can't detect the ISM because we're inside the cocoon of the sun's, of our magnetic field.
Steve, tell everybody what the ISM stands for.
Interstellar medium. It's the material between the stars, which is quite different from the material inside the solar system.
Yeah. What did Voyager come up with? It was less dense than the solar system, and that we're seeing a steady flow of electrons moving in.
Yes. There's the Strahl effect, where some of the charged particles leak through the electromagnetic field surrounding the sun. So you have enough energy to power the sun. You know, it's called Strahl, S-T-R-A-H-L, the Strahl effect. So where does the energy come from to power the sun if we're enclosed in this electromagnetic ball? And the answer is it leaks. It leaks.
It
because
does.
So much. Imagine the energy density of the interstellar medium. You know, it's a tremendous force coming from all the stars in the galaxy, all of them heading toward us.
I see.
They have their own filaments, right? All the stars have their filamentary connections, and they're all connected with each other, and they're all connected to us, to our sun. That's what's powering the sun.
Yeah.
And what's amazing is when you start looking at that, when you take Halton Arp's idea that galaxies are connected with these lanes, and then NASA, Matt, this is what you were talking about the other day, that NASA just discovered these filaments that are connecting galaxies, and you realize the scale, or you think about the scale, gargantuan.
Just scale is really meaningless.
Yeah, I mean,
it's just all of a sudden
up, infinitely down.
All of a sudden, the filaments connecting us and the sun seem like nothing compared to these filaments outside in the galaxy and between galaxies. You're like, where does the electricity come from? There.
Why do galactic filaments collect into lanes? You know, like spiraling out from a center.
That's such a good question. I love that question.
No one knows. No one knows. It's one of those no one knows. How
and the Vega cluster is what, a couple trillion light years long, as far as we can tell. I mean, when you're talking about scales, so I think Mike Claridge has it right. It's all a big brain.
when Mel and I were first interacting back maybe almost 20 years ago now, we were talking about that there probably are only two major mass concentrations in the universe, the Virgo cluster and the
really?
There's two major clusters.
I can't think of the other one either.
These are superclusters. The Virgo supercluster is on one end, and the
let me see if I can look it up real quick.
I can't remember. I can't remember.
A few moments later.
Lecanea?
No.
Lenikea?
No, that's the filamentary structure that's supposed to contain all the superclusters.
A few moments later.
Huh?
Perseus Pisces?
No, not Pisces.
Coma, Shapely, Hydra, Phoenix.
A few moments later.
Oh, supercluster.
Look at all that hair. I'm so jealous.
Who? Oh, you mean you're talking about me?
Yeah, we're talking about yours, Steve.
I get a nice shine up there when I try to do that.
Let's see, dark flow. Greater and greater.
A few moments later.
It's Hydra. Yeah. There are only two superclusters, Hydra and Virgo.
Is this by like a size definition kind of deal?
It's ARP's idea because of where everything is coming from and where it's all going.
I got you.
Those are his two electrodes.
Oh, I see.
The two superclusters. Oh, and this goes back to how galaxies occur in strings.
Well, that garden hose idea I had, it probably would apply to galaxies too, just like it does to solar systems. So you've got immense intergalactic Birkeland currents where you've got these disks along them acting like little electric motors or big electric motors.
Oh, yeah, loads in the circuit.
Yeah.
Galaxy string known as Markarian's chain. They occur
Did you find it?
Yeah.
They occur along plasma ropes, is Hydra.
Oh.
But yeah, the two superclusters that HARP envisioned as the two electrodes.
Wait, are we talking about ARP or HARP?
ARP. ARP. A-R-P.
ARP. Okay.
Halton ARP.
Gotcha.
I keep wanting to say the H after. I want him to be called
for hurricanes, but
I want him to be called Alton Harp.
That would be easier.
Where are you guys?
So one of the main things the mainstream model discounted ARP's observations for is because they said there was no predictive framework to fit them into. But he kind of turned electric universe toward the end of his days, and with the discovery of that new plasma current, intergalactic plasma current, wouldn't you say electric universe has become the predictive framework he lacked?
Well, maybe. I mean, as time, because his interactions with the group were like 30 years ago.
Mm-hmm.
I realize. Like 2005 is when Amy Atchison died.
Yeah.
So that's 20 years ago.
Wow.
And ARP died, I think, just shortly after that.
Yeah.
There wasn't a long period of time for association. And then after they both died, a lot of development occurred. A lot of new people came in. I took Amy's place because she died. And she was writing the picture of the day.
Mm-hmm.
So they gave that to me because of, I don't even remember why. It was 2007.
Right. Well, even if he didn't know it, one thing we can be fairly confident of is that his observations don't line up at all with the standard, cold, dark
Have you
matter.
seen ARP's presentation where he's talking about intrinsic redshift? Have you seen that video on YouTube?
Yeah.
Yeah.
I've got
it really
book,
lined
too.
up well with the EU.
So long ago, he's using grease pencil, on a projector, grease pencil projector, right? Light table.
Yeah.
Yeah, he has those black and white hand-drawn images of various galaxies and such with their redshifts.
Yeah.
That just blew my mind. Seeing redshifts of Z equals 3, right next to redshifts of Z equals 1. And you're going like, God, how can that be farther away?
Yeah, isn't that like a trillion light years or something like that?
The
These
Z
are ridiculous numbers.
Yeah, the longest Z now that they've got was James Webb is Z13. So that's as far as they've been able to see.
Yeah.
What's fascinating is I've got his book Seeing Red, and it's you read alternate theories, in different science fields, but his are, one piece of evidence, one thing that he found just destroys the current model unequivocally.
Yeah.
Unequivocally, like what you're saying, like when you see the different Z values and you see that they're linked, and you're like, well, wait, what does a Z value mean? And you realize the Z value means that there is a colossal distance between the two, and you're like, well, wait a minute. If there's a colossal distance according to our model, and they're connected, then our model's wrong, isn't it? Yeah, unequivocally.
Yeah. You also have to start asking questions about things like distance.
Uh-huh.
What does it even mean? And you got to ask questions about mass.
Right.
Nobody knows what mass is. Mass is the bottom of the lexical well. That's as far as we can say what anything is. Oh, it has mass. Well, what does that mean? It has mass.
Right.
It's like charge. charge, length, mass, any of these physical characteristics, we don't know what they are. We can't, there's nowhere to describe them below those words. There isn't anything holding them up. It's like they appear.
Yeah, this is a fascinating time to be alive. It's like we're the ancient Greeks wondering what the hell's across the ocean. I mean, with that Big Bang model going away as it needs to, we're in uncharted waters completely. And, you've got ARPS observations that match perfectly with the electric universe predictive success with those Birkeland currents just discovered. So it seems to me we've got a real working model here. We just need to get in front of the right people.
Yeah. But can you imagine a universe that quadrillions of light years away, quadrillions upon quadrillions of light years away, is another universe where we are having this discussion, except you have red hair.
Oh, poor
That's
baby.
it. And that's the only difference out of the entire universe's evolution and existence. That's the only difference that has ever or will ever exist. And then quadrillions upon quadrillions beyond that is you have red hair. It's just like, and then every variation of all the infinite amount of variation that can even be processed in our minds occurs and exists. That's the horror of an infinite universe. Is there's no getting out.
There's that other idea that's it's what is it? Trying to think of his name. That physicist who was actually, his ideas are now accepted, but at the time he was made fun of so much that he left physics. And it's the many worlds theory of quantum physics, but it's the same idea. It's like every single moment bifurcates into another universe. And then that moment bifurcates. And then it just gets so big and so crazy. Just like,
you hear it often discussed where people will say every decision we make fragments the universe. I voted for Trump. I voted for Lee Harvey Oswald. It doesn't, that's where the bifurcations occur. And, but people think, but that's wrong. That's absolutely wrong. That's such a subjective and, what do you call it? Narcissistic viewpoint. In reality, every atomic vibration bifurcates the universe. Every atom's vibration sends out a new wave that needs to be collapsed. And who are the decision makers? Who is the observer? What is the observer? Where is the observer to collapse the waveform? To create that universe that you just discussed, Ben.
Right.
That's the reason I have problems with it, is because it's highly subjective.
So in this electric universe, is it fair to say that it doesn't really work on an atheist? It doesn't mean you have to be a particular religion, but it seems like there's got to be some kind of overarching consciousness out there.
Well, I think so, just in general. I was an atheist. First, I started out as a Christian from when I was a teenager until I was a Christian for 33 years. And in fact, I became a theologian and developed my own view of hermeneutics, or the principles of studying the Bible. I had a little following and people would send me money, that kind of thing.
Wow. So, genuine cult leader, man.
I'm a genuine cult leader. An intellectual cult.
I'm trying to start my own. You'll have to give me some.
There you go. But after a while, I saw there were too many things that I saw as problematic. And so I became an atheist until I could perhaps sort it all out. So that's when I joined the Electric Universe group, because I was an atheist. And that was appealing to me, that I could have a story to tell that didn't involve, God or just even the philosophical idea of a creator or designer.
And yet it's kind of weird the way the Electric Universe really lines up with a lot of religions.
A lot of religious people join Electric Universe. Like I was telling you guys, about Anthony, Anthony, the guy that was the Mormon.
Mhm.
Oh yeah.
Can't remember his name again. He even found it. But there are a lot of people like that, but there are a lot of atheists, like Mel and me. We were atheists, and Wall's an atheist, and Don's an atheist, and Dave's an atheist, and
I
Dave,
was too at the beginning.
Dave's a spiritualist. He's not
Mhm.
necessarily an atheist, but he isn't a Christian, you know.
Yeah.
All gods, all flowers must have room to bloom, you know.
Right.
It's his attitude.
The electric
After a while,
universe. Oh, sorry.
as I've gotten older, I'm starting to think that either everything is solipsism, like I jokingly said earlier, and that when I die, the universe will end. In some respects, that's true, but
It
you know,
is. It doesn't mean solipsism is true, but in a very, very real, tangible sense, the universe will end for you.
that's right. If there are no thoughts in my mind, there is nothing to think about.
Well, for the biomass, yes.
Right.
I've heard a YouTube video that blew my mind the other day, and it suggested that the thoughts in your head, the itch on your arm, none of that stuff is you. You are the observer that's watching it all.
Right.
Whatever that is.
Right.
And that never changes whether you're happy or in pain or whatever it might be.
Right. That's what I always tell my cousin, nephew. He has some emotional problems similar to schizophrenia.
Mm-hmm.
I just tell him all the time, look, those are not you. Those feelings are not you. You're the one feeling them, experiencing them. So that means you can decide what you do with those feelings because you're the executive. You have the pen and you can sign the papers and make them do whatever you want. And that helps him periodically, realizing that he's the one deciding. He's the one thinking, not experiencing. He's not the one experiencing. He's
Right.
the one observing the experience.
Yes.
And when you pay attention to those situations where you have thoughts and let me go a little bit out there even more, voices in your head, think about that for a second. You're actually and you realize that there has to be something more that we don't know about because there is the you that listens to another voice in your head. And then there is another voice that said, one says, you're a piece of crap, and the other one says, no, you're a really good person. And then all of a sudden you realize, wait a minute, who are all these people?
Yeah.
Why would I ever have a thought? If I'm a sentient being that wants to stay alive more than anything, why would I ever have a thought that drives me into dark impulses? Why?
Because you have an animal side of you that just does what animals do, and then you have a civilized side of you that tries to guide you to reason.
Hold on. The animal side of you, like animals, other four-footed quadrupeds, whatnot, they want to stay alive as well. They fight to stay alive. So we can't just say it's the animal side that gives us our dark impulses that lead to our destruction. It can't be that. I mean, I see what you're saying.
Well, it's more like, let's say you see some food that you want to go jump on, and if you were an animal, you would do that. But if you're with a tribe, you might have a good reason not to do that. That might be founded in morality, which is something that might not jive with your animal self. So you're going to get that inner dialogue. Well, you're a piece of crap because you're not going to get this food. But then on the other hand, I don't know.
Well, there are two yous, essentially. I used to call them me and I. Me ducks when a ball is thrown at me, or hides my eyes when the light's too bright, or claps my hands over my ears when it's too loud. I don't have to think about that. But I learn music. I learn what color is. I learn science. I learn, I train my me to those empty cerebral cortex cells, the undifferentiated cerebral cortex that only we have. Yeah. No other animal has undifferentiated cerebral cortex. So we're able to internally train our minds to learn things. But throughout the entire process, We still spit out what tastes bad. We still pitch our noses for a bad smell. That cannot change. It will always remain. So those are the two factors in our consciousness, at least. But you know that our learned consciousness, the I, lags behind the me by about 9 milliseconds.
That it does.
Yep.
That it
So
does.
we do things that we have no conscious awareness of until 9 milliseconds later.
Sorry, go ahead.
No, I was just saying, like you mentioned, Matt, we're observers. We're observers of our lives. We are not living our lives. We're watching our lives.
Yeah. And you experience that delay all the time. That's what deja vu is, right? Like when you have something that goes to your memory banks before it goes to your processor because of some glitch in your brain, and then when you observe it, it feels like a memory.
Right. It's the delay in perception of the observer.
And that's another big strike against Einstein, or I don't know that Einstein, but the idea that time is a thing is that really it's probably different for everybody perceiving it. And it probably has to do with how long it takes the signal to get from your eye to your brain. So a fly probably sees us going around in super slow motion.
Yeah.
There's a very real instance of this where with foot races, or like with car races, you know, they wave the checkered flag when they finish and they wave the green flag to start the race, but they don't do that with foot races. They use a gun because the auditory nerve is actually shorter than your optic nerve.
That makes such total sense. Have you ever had a dream where you'll hear like a car wreck and you're dreaming about it, or it could be any noise, and then you wake up and you realize, how was I dreaming about that when I hadn't actually heard it yet? And the sound that you hear just fits right perfectly in your dream. That made complete sense.
Yeah. Well, I had an experience that I thought was remarkable. It was only once and very short, but I was sitting around a table with several friends, and suddenly this clanging noise started happening, like clang, 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 clang. And in the midst of this clanging noise, it was not audible. You know, no one else was hearing it. I could tell.
Yeah.
In the midst was a sentence. Someone was saying, "I didn't know I went there." And then it all went, "Ah." And the woman across the table from me said, "I didn't know that I went there." And I went, "What the hell?" I had to stop everybody. I said, "Look, something just happened. I must tell you about this." And I went, "What? What? You know, what?" No, there was no explanation for that. It was like it was like the frequency kind of altered a little bit, and something got ahead of what shouldn't have gotten ahead and then went back to its normal flow.
Could it have been a hypnagogic? You know, when you're falling asleep and you get those really loud, sudden noises?
Yeah, but it was just sitting around a table like you do every day, just with your friends and talking and stuff like this. And then the clanging noise in the midst of all of it started appearing in my mind, in my ears. And I didn't know, you know.
I suspect that when people are schizophrenic, where they can, I'm not calling you schizophrenic, when people are schizophrenic and they like see an imaginary, I'll bet you there are times in our lives where whatever mechanism in your brain runs your dreams turns on while you're awake.
Could be.
Yeah, and you're probably dreaming while being awake. And people think that, oh, I can tell the difference between a dream and reality, but no, you can't. It's the same equipment.
You know, Alphane waves go about at 9 hertz, and that's the same frequency as your brain is 9 hertz. So maybe Alphane waves are carrying our consciousness in some respects. Something related to this happened to my girlfriend at the time. She and her friend were in the car driving to this ice cream place where they were going to get a ice cream cone. So they were chit-chatting about, you know, this and that and the other. When they pulled up to the ice cream place, they got out of the car, and there was this woman with obvious mental conditions, you know, all bundled up against the cold and smoking cigarettes and just saying things, you know, to the air. And all of a sudden, she said, the woman started repeating their conversation that they had had in the car driving up to the ice cream stand.
Whoa.
Oh, that's wild.
She's like you were saying about schizophrenia, maybe these balances between the frequencies, get off kilter sometimes and something kind of sneaks in.
Well, our brain is built like an antenna. Consciousness does appear to be something beamed into us. And I used to be able to guess radio shows or what song was going to be on the radio before I turned it on all the time. There's something to it. And then now we've got D-class CIA files talking about astral projection as though they're actually happening.
Yeah.
It's hard to, I don't know, but I've never experienced it myself to the point where I couldn't say it was a lucid dream, but I have seen some strange things.
Let me interject something. I did an experiment with a kid years ago where we got a 10-gallon fish container and put some water in it and dropped a rock in it. And then I just filmed that. We made a little tsunami, right? That was for a science project. And I filmed it in slow motion. And guys, I saw something, and I've talked to some other scientists about this, Dean Radin and Gerald Pollack about this. We don't have any explanation yet. But there is a phenomenon that was visible on this video of what I'm calling a pre-wave. A pre-wave. As I drop the rock and it hit the surface of the water, of course, you can imagine that it creates a huge tsunami wave. Mm-hmm. But under the video, you could see preceding that large wave was like 7 little tiny waves.
Oh.
Now, if you take that concept of a pre-wave, all of a sudden, a lot of the instances, Steve, that you were talking about start to make sense. That we can actually, and that coupled with the fact that our subconscious brain is a lot quicker and faster and perceives things a lot faster than our conscious brain.
All right.
But it also opens a door to a gigantic room of like, what the hell's a pre-wave? What universe do we live in that something can happen, have an effect before it happens?
Before it happens.
Well, the object gives off its own magnetic field of some sort, right?
Say again?
Would the object give off some sort of field that might make contact with the water before the object itself does?
Sure, but that's what I measured. But how? How do you get an effect prior to the cause?
Quantum physics.
Quantum physics. Quantum physics says that.
Because that's what they say. Yes, there's no cause and effect in quantum physics.
But what was crazy is that I actually measured it. In fact, you can do this at home. It's easy. Just get a dish of water, drop something in it, and film it in slow motion. You'll see those pre-waves go right up to it. It's
could be air pressure
while the rock is in motion, as it's heading toward the surface, or as it just touches the surface?
No, the pre-waves occur before, as the wave progresses down the water. So the waves don't appear.
The rock plunges in, and then the bulge begins to occur, but behind the bulge are these small little rivulets or wavelets.
In front of the bulge.
Oh, in front of the bulge. Like they're happening before the major bulge.
Could the falling object be pushing air and the air be contacting the water?
Crystalline water.
What's that?
Crystalline water.
Right. That's why I talked to Gerald Pollack about this, because I think easy water. But, to our simple little Neanderthal explanation, it looks like something is happening before it's happening. Do I think that's what's actually going on? No, I don't. But that's what it looks like. And when we experience things like, Steve, what you just talked about, it feels like something mystical is happening, something magic, something that's unexplainable.
Precog. Remember that? Precog from, what was that called? That movie with Tom Cruise?
Yes, it was a Philip K. Dick.
The pre-crime one.
Pre-crime, yeah, that was.
I can't remember what it's called, but yeah.
Good movie. Minority Report.
Minority Report. Yep.
That was one of my favorite movies for a long time.
That was a good film.
But man, God, are we covering the gamut of stuff?
Well, did we ever actually talk about
Geology?
geology?
Well, we started to by the when we talked about the solar flares connecting to the ionosphere in a sort of a transformer effect, and then linking with the telluric currents, and that the lightning bolts could initiate a thunderclap within the rock strata, and that's what earthquakes are.
Right.
Who's the Thunderbolts guy that does like the supersonic winds that shake mountains?
Andy Hall.
Andy Hall. We need to get him on too. He'd be fun to talk about this.
Yeah, that's all part of the Velikovskian ideas of how the Earth's surface was created.
Mm-hmm.
For example, where did 5,000 feet thick of the Apache sandstone come from, covering hundreds and hundreds of square miles? So fine-grained, it can be napped like flint.
Right.
5,000 feet thick. And so fine that it's almost, you have to use a microscope to see the granules. Where the hell did that come from?
I have an idea.
And the Ogallala Aquifer underneath the Midwest, under Kansas and Nebraska and all those places, it's like 300 feet thick of gravel, all full of water. And the farmers in that area have been using it for centuries to water their crops. But the problem is once you drain the water, the rocks all compress and you can't rehydrate it. So it's been there as a one thing. The gravel and the water were deposited as a one thing all at once, and then covered over with hundreds of feet of sedimentary deposits.
Like, oh, I don't know, should we say a intergalactic thunderbolt hit the planet, pulverized stuff, fell back, we get water from Saturn, and then these supersonic winds just cover everything over.
Cover everything.
Also, is it fair to say that if there is high-speed electrical interactions happening at the Z pinch inside of our sun, or rather on the photosphere, and we're getting low-level nuclear reactions that are creating the stuff of creation, and it's being sprayed out across the solar wind and raining down on the planets, couldn't that explain why we're a portion of the Earth's water? That's why we're getting water up in the ionosphere where it clearly can't evaporate to?
I don't know. You know, a lot of this stuff happened so recently that it's just now beginning to dissipate. You know, I think many things happened like in the Middle Ages. I think electric discharges periodically over history.
Yeah.
And Velikovsky was wrong in assigning them only to like 687 BC was his latest interaction.
And you can't blame, because he had to work with the standard model of millions of years. But now we can start thinking about things a little more realistically.
He had to go visit a library. He had to go visit a library and pull card catalogs and look at books, Velikovsky.
My God.
He didn't have the internet. He didn't have anything. He didn't
How
have
did he live?
Yes, how did he live?
And this was just
why he was so grumpy.
And think about
damn it, I had to read 30 books again today.
I'd be an asshole too.
Yeah. And this is just a few decades ago that this happened.
Right. Yeah. Right.
I mean, my favorite part about these discussions is that we live in an age where you couldn't even conceptualize the things that we'll be talking about 20 years ago. Like the whole idea that there could be simulation, like that didn't exist. I mean, Plato kind of played with the idea, but I'm a big believer that we come from advanced civilizations. The flood wiped out a far more advanced civilization than our own, and that what our religious writings, like on the Sumerian stones, is a retelling of a world more like ours than the Bronze Age world that interpreted those warnings or messages. And how do you explain to a Bronze Age yak herder what the internet is or what a simulation is? So now we can debate those for the first time.
You read these old documents like the Seven Gates, where they sent the guys out to find out when was dawn and when was dusk and what month was it, and what season are we in, because of the destruction that had occurred, which implies that there was survivors, throughout all of these time periods.
Survivors, Steve, and this is something I just came to realize in the last few months. In fact, it was probably with our earlier conversations, is that if you had to send out people to find out what the time and date was, it means that everything that caused time and dates to be understood changed.
It
The
was
skies make
a different sun,
Different sun,
sky.
different rotations, different positions. All of that had to have changed.
Right. And they did, according to Velikovsky.
Yeah.
And they did.
Everyone thinks, a lot of people think that there was a massive change, in everything, in the corpus of reality. But people think of different ways that it changed. Velikovsky and Dave and Wall were the planets.
Right.
Venus and Mars. And Schock, taking after Peratt, thinks it was lightning storms caused by an overactive sun, causing this intense heating effect. And by the way, in your area of the world, Ben, all those sandstone cliffs with the blackening all over them,
Yeah,
those are fulgurites. The blackening is the edge of the lightning bolt, where it burned through the rock. Where if you have a canyon with steep vertical sides on each side and the canyon walls are blackened, that's where the lightning bolt channel cut the canyon. That's why the Grand Canyon has blackening over all of its rock faces on its vertical cliffs. They're all blackened, especially the sandstone, because that's the lightning bolt that carved the Grand Canyon.
right. So two things about that. So Navajo Mountain is right down there in the same thing. If you haven't looked at Navajo Mountain on Google Earth, please go look at it, because Steve, it is exactly what you have. You have this blackened peak that's right there of Navajo Mountain, and you zoom in, and you're like, why is this black? And you look at it, and then it dissipates, and so you realize that's the channel of blackening. But then the second thing, which is fascinating, you're like, wait a minute, wind and water would erode this away over time, which means this blackening has to be really recent.
Really recent.
Like not millions of years, not even hundreds of thousands of years, but maybe a few thousand, maybe
Younger Dryas.
1,000.
Thousand
Yeah,
years.
exactly. And so when you grab a hold of that concept and you start looking at the geology, we're going to come full circle now, the geology all around you, you're like, wait a minute, this geology isn't millions of years old. The rocks may be, but the geology, the actual formation, is very, very recent.
The surface is young.
Yeah. The rocks have been here since we orbited Saturn, or what was the other one called? Uranus?
Uranus, the original.
Uranus.
The original.
So the rock is old, but it got refaced when we took up new orbits, and we went from a small gravity, because small electrical input, which is why we had plant and animal giganticism, into the sun's electrical environment, where we have much stronger gravity, and the biggest terrestrial animal that can move in our gravity is an elephant.
Did you ever read that little article that who's that guy, kind of heavy set, short?
Yes.
What's his name?
I don't know, but I've seen
where
his
he talked about the
before.
Brontosaurus.
I'll look it up and edit it in.
He talked about the Brontosaurus, and how it could not walk in a 1G gravity field because
the muscle tensile strength is,
Yeah,
you'd need structural steel.
Yeah, that its belly was so huge that the gravity of a 1G field would just rip the belly right off the dinosaur.
Wow.
It was so massive.
And their heart wouldn't be able to pump blood. Like when you look at the size of a giraffe's heart to get blood up to its brain, with a brontosaur, or like no such thing as with a brachiosaurus or diplodocus, its heart would have to be just ridiculously big to be able to do the
size of a Volkswagen.
Yeah.
But how is it going to get enough force to overcome, what do they call that? The angle of moment,
I don't know.
that drives compression.
So, kids, there's actually more to this story, and I'm completely in agreement with both of you. But Dr. Gerald Pollack, in his book, The Fourth Phase of Water, discusses how the human heart suffers that same problem. That it actually, when it comes to pumping blood through all the capillaries, our heart actually can't do it. And he uses his whole idea of easy water as an energy source to justify how blood can get through our capillaries by our heart. That it's not our heart doing it, that it's the energy, it's the electricity, the charge from easy water that's actually pushing our blood through our capillaries.
My buddy Norm always talks about this. He keeps telling me the heart isn't a pump, and I thought he was nuts. Maybe I'll have to bring him on. He can explain it.
Right.
It's a vortex generator.
Oh, that's much better.
The blood is actually going through the capillaries and articles in a vortex. It's spinning.
Oh,
right.
As above, so below.
Yeah, everything spins.
Yeah.
What was I about to say? There was something about the heart and blood and all that.
We were talking about dinosaurs.
Dinosaurs, yeah. That disappeared quickly. No, the dinosaurs, what was it that I was going to say? There's something about, never mind. It'll
pop up. We'll edit it in.
Hey, we're going to have to do another edit here. Someone just knocked on my front door. I have to go see who they are.
Well, do you want to wrap up?
I think we're going to have to wrap up. Is that okay?
Yeah, we got a pretty good line show here. Let's call that a wrap.
I'll let you guys say goodbye to each other. I'm going to have to
see you, Ben.
now.
We'll both go. See ya.
Right. Goodbye, everybody.
Locking out.
Bye-bye.
Thanks for listening to the Brainstorm with Sparks and Finn. Hope you learned something new or found some food for thought. Join us next time as we explore this amazing electric universe. Cheers!